Hello and welcome to the third lesson in Unit 5, Rational Exponents. Today we're going to take a look at exponents, and in particular we're looking at rational exponents, and rational exponents simply mean fractions, so a over b. Alright, and we want to know how to evaluate them using our heads and using a calculator. So first of all, rational exponents. I'm going to give you a couple of examples and we're going to pick up on a pattern here. So if I had 4, let's say, to the exponent 1/2. On the calculator, I'll punch it in, and I get an answer of 2. If I had 8 to the exponent 1/3, I'm going to tell you that the answer is also 2. And if I take that one step further, 16 to the exponent 1/4, we find that the answer for this is also 2. So you can check this with your calculator yourself, but that's what it gets, what happens when we have those exponents of 1/2, 1/3, and 1/4 for those particular values. So what's really happening here? Well, if we look at the first one, and I ask you, have you ever seen, or what operation would result in getting 4 becoming a 2? Most of you could likely come up with saying, well, if I take the square root of 4, I'll also get a 2. So that must mean that if I go 4 to the 1/2, well, that's the exact same as taking the square root. So following that logic, how would an 8 become a 2? Well, it's not going to be just a square root this time. We must be finding what's called the cube root. So if we have 8 to the 1/3, that must be the equivalent of the cube root of 8. And similarly, the 4th root of 16 is also equal to 2. So 8 to the exponent 1/4 is simply saying the 4th root of 8. Okay? So what we're finding in there when we're doing these calculations, alright, so for example, I will take the 8, for example, put a line across here. So 8 to the 1/3, in the calculator it's saying find what number multiplied by itself 3 times, and that comes from that denominator of a 3, so by itself 3 times to get 8. And we find that, therefore 2 times 2 is 4, times 2 is 8. That's why that answer comes out to be 8. Now, what happens if, and this is for the also category here underneath, okay, what happens if I had, and I'll use the same numbers again, 4, but this time I'm going to go negative 1/2, 8 to the negative 1/3, and 16 to the negative 1/4. If I punch these in the calculator, and I'll do that for you, the answer is going to be 0.5. The next one will be 0.5 and 0.5. Now, why is that? Why is it giving us a decimal this time, that negative sign? Well, the reason for that, we'll start with 4 to the negative 1/2. Yesterday, or last day, in the lesson you dealt with your exponent laws. So what happens when we have a negative exponent? Well, to make it a positive exponent, we rewrite it in the denominator. And we just talked up above that 4 to the exponent 1/2 is really 1 over square root of 4, which is equal to 1/2. Alright, so if we have negative exponents, you're going to do the exact same thing, except you're just going to put them in the denominator, and I'll show you some examples with that in a second. So, how about if we have something like this, 8 to the exponent 2/3. What we want to do with this is we want to break it into parts, and we're going to use our power of power law, except we're going to go backwards. So how did I get 8 to the exponent 2/3? Well, in brackets, what I'm going to do is I'm going to say whatever was in the brackets was squared, So really, I have 8 to the exponent 1/3, and I'll put over here as a star that 1/3 times 2 is equal to 2/3 as a reminder. So we can break that apart, because now what I can do is I can treat this in stages. So 8 to the exponent 1/3, where I talked that above, what times what will give you 8. So we find that it's 2 squared, and the answer is going to be 4. So we're going to break it into parts like that. So, some examples. All our regular exponent rules, they still apply. Okay, so everything you learned in the last couple of lessons, we will still do moving forward. All right, so some examples here. So what we want to do, we want to do these questions, and we're going to do them without the calculator. All right, so knowing that, we'll look at the first two here. So the first example, evaluate without the calculator, negative 32 to the exponent 1/5. So in my head, I know that this is the same as the 5th root of negative 32. So what I'm looking for is what multiplied by itself 5 times will give me 32. And you start going through the basics. So you can start with 1, but 1 times 1 times 1 times 1 times 1 is just 1. You go to the next one. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I'll just put that there. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So that's just what's going through my head. So I used a total of 1, 2, 3, 4, 5 2s. So the answer here is going to be a 2, but it's negative 32. So because it's an odd number of 2's being multiplied together, the answer will be negative 2. All right. Again, without our calculator, 16 to the exponent negative 1/2. First thing I'm going to do, I'm going to rewrite it with a positive exponent. So I'm going to use my exponent laws from the other day. And I have 1 over 16 to the 1/2. Now, in my head, and I'm going to put an extra step in here, I know the exponent 1/2 is like saying the square root of 16. So 1 over the square root of 16, my answer here is going to be 1/4. And that's my final answer. All right. Next, take a look at that third example. Same thing with 100, positive 100 to the exponent 1/2. I'm going to look at it in terms of exponent 1/2. Well, that is just a square root, and the square root of 100 is 10. And my last example that I have here, I'm going to rewrite this using our power rule. All right, so with that power rule, I'm going to rewrite this as 64 over 27 to the exponent 1/3, and then all of that squared. So the first thing I'm going to do then is I need to find or determine what is the cube root of 64 and 27. So again, we know that 2 times 2 times 2 is 4. So that doesn't, or sorry, 2 times 2 times 2 is 8. Next we try our 3's. 3 times 3 is 9, times 3 is 27. So that tells me that the cube root, and I'll do this off to the side as just with a star here. So I know that 27 to the exponent 1/3, that's the cube root of 27, and that'll get me a 3. So that means on this side here, we have a 3. So I got to find the top yet, the numerator, so I'm looking for the cube root of 64. So the cube root of 64, it can't be 3, 3 is 27, so we'll try 4. 4 times 4 is 16. 4 times 16 is 64. So now I have 4/3 squared, and our exponent laws from the other day, every exponent in here gets squared, or every term inside gets squared. So 4 squared is 16, 3 squared is 9. So my final answer then is 16 over 9. Now, examples here for us. Now we're using the calculator. So this is going to depend on what calculator you're using. So now we can't do this in our head, and we can't do this in stages or steps. So what we will do is we will figure out what buttons to hit on the calculator. And there's two types of calculators. All right, so calculator type 1, you're going to punch in 0.008, and then you're going to find your X to the Y button. Then we need to use a bracket button, and you're going to go 4 divided by 3, closing bracket. And you can hit equals, and that will get your final answer. Calculator type 2, you will need to, type 2 is if you have a script calculator. If it's a script calculator, you just write it as is. So with the script calculator, spell here, you write it as is. All right, so I'm going to calculate these for you. You need to go ahead and try it with your own calculator. You need to make sure you know how to use it. So again, it's important to be using the same calculator over and over. So for the first one, please make sure with your calculator you can get 0.0016. Now the next one, we don't really have, some calculators will have a fifth root one. I believe the script calculator will handle this, but for myself, when I'm using my regular calculator, I need to do this extra step. The fifth root is really that number to the exponent 1/5. So now I can treat it the same as I did with the first one. So punch in 0.00243 bracket 1 divided by 5 bracket, and please make sure you can get this with your calculator. 0.0, let's see here. I'm going to have 3 zeros, 486. All right. If you have any trouble with the calculators, let me know. Use the homework that's assigned on the website.